Least recently used memory is the most likely to get kicked out, with exceptions made for how complex it is. Okay. And it also engages two processes that you probably have seen if you've ever done an SP who statement or looked at the activity monitor in SQL Server Management Studio, or maybe you've used the great stored procedure SP who is active. It's going to use the lazy writer and something called the ghost cleanup process. Okay. And so again, from the big diagram, we had the Windows RAM buffer pool, which is divided not just into the data cache and the plan cache. And we could think of those as having probably, it varies a little bit, but we could think of the data cache as being like 70% of SQL Server's memory allocation, and the plan cache as being 20, maybe 25%. And again, they can go up and down. And it also is affected heavily by the version of SQL Server. And then there's also lots of small other caches. There's a sort cache, there's hash buckets. If you use extended events, each extended event trace you create has its own little buffer, log buffers. So there's lots of small ones, but the two big ones, data cache and the plan cache. And I'm going to illustrate how the LRUK works with the plan cache because it's a little simpler, but the principles are the same. So when we invoke a piece of code, whether that's an ad hoc query or maybe a stored procedure, what happens is SQL Server creates two pieces of metadata it tracks for each of these different pieces of code. One is the complexity value, which is K over here, and the other is the complexity countdown timer, okay? And if we invoke a new one, it's much more complex. It's more than twice as complex as the next most complex one in the cache. SQL Server then invokes this process called the lazy writer. And the lazy writer is typically invoked every few seconds, but it can be invoked by request from any of the worker threads. So the lazy writer looks around and sees if any of these objects in the cache haven't been used in a while. And so it decrements that countdown timer, right? And you see the very simple ones down at the bottom, they're getting low on their counter. It goes away for a little while, maybe a minute, and it goes through the cache. And as before, it decrements all of the different countdown timers by 1. Each time it goes through this process, it decrements them by 1, okay? And notice that some of these hit 0. Okay, well, what's going to happen now? So what happens in this case is, when I first learned about this, I thought that SQL Server, clearly it's going to evict that procedure from the cache, right? Well, actually, the correct answer for every technology question, particularly in databases, but I think in every situation, you could say it depends, right? So what does it depend on? Well, what happens here depends on memory pressure. So if the memory is kind of open and there's plenty of open space, open territory in the plan cache, then why throw it away? Why evict it from the cache? Somebody might come along and ask for that if there's no memory pressure. If there is memory pressure, though, we're not actually directly going to evict it from cache. What we do is we flip a bit in that header information, the metadata information, and we mark it as ghosted, so that the ghost cleanup process, which is our kind of garbage collection service, the ghost cleanup process will then evict it from the cache, right? At the same time all of this is going on, other users are entering new things into the cache, other things are aging out and being evicted, or maybe hanging around a little bit longer. And if the lazy writer looks around at all of the objects and it sees one of these has been used since it was last there, it restores it up to its maximum counter value that it started with. So the idea is if you have a big query that gets used a lot, well, we want that to have a lot of chances to stay in the cache because it's really expensive to build a new plan for it. On the other hand, if it's something like a really simple query, goes to phase 0, well, we can recreate those quite frequently. And in fact, SQL Server doesn't even maintain trivial plans in the cache. That's its default behavior. It lets those get evicted by the ghost cleanup right away. So they might be there for, a millisecond or 3, and then they're gone. So you would have to use a trace flag to enable trivial plans to stay in the cache for any duration at all. Now, you might be wondering, okay, well, what about the data cache? Okay. The data cache essentially is similar, except the big difference between the plan cache and the data cache is the data cache can have a lot more kinds of objects. So it can have, databases, tables, partitions, clustered indexes, non-clustered indexes. And so it has to manage all kinds of these different objects at the same time, but it uses the same kind of principles to manage the data cache. Okay. Now, the next section also to talk about is how the SQL Server, the SOS, and the threads work. And the reason this is so important is because it provides you kind of an entree into one of the most effective starting points for good troubleshooting, which is weight statistics. So what happens is, let's say Sheldon connects to the server. He's assigned a SPID, the system process ID, a thread number. He's number 55, and he's on the running scheduler. He gets a quantum, something called a quantum on the CPU, a time slice of 4 milliseconds. Chances are pretty good that whatever he wants to do is going to take longer than 4 milliseconds. So there are other queues associated with the threads getting their work done. The first of those is the suspended queue. And now notice it says scheduler 1 on each of these. There's a scheduler for each of the addressable CPUs, I guess you could say, on your machine. So if you have a computer that has two, what do we call those? 2 of the chips on the die, and each of those have 4 cores, and then you turn on hyperthreading, SQL Server would see 16 CPUs, and it would create 16 schedulers. Okay. So Sheldon gets a few milliseconds on the CPU, and meanwhile, there's all kinds of other people trying to do work, but they're not able to get their work done because they're stuck somewhere on the city block in Manhattan, right? They're waiting for the query optimizer to finish. They're waiting for their locks to be granted. They're waiting for a memory grant. There's a shortage of memory. Maybe they're waiting for the transaction log to finish. So you'll see all kinds of threads that are in the suspended queue, and they are now exhibiting a weight statistic type. So if, for example, you were to see LCK, this means lock, mutex, shared. So a shared lock is a select statement. Page IO latch shared means that SQL Server is retrieving data from the IO subsystem to load it up into RAM for a shared operation, right? A share meaning a select statement. So we've got all these different schedulers, all these different SPIDs. They have their different resource weights. On the other hand, we do also at the same time have some threads that have gone all the way around the block. They've completed and gotten everything they need except time on the CPU. So those are all called runnable. They have everything they need. And we also call those signal weights because they're kind of like a player on the, on the edge of the pitch. And they're like, put me in, coach, I'm ready to play. So they're giving the signal that they are ready. So as different threads get all of the resources they need, they are moved into the runnable scheduler, put on that queue. Meanwhile, because it took too long and Sheldon exceeded his quantum, his 4 millisecond spin on the CPU. He is moved into the suspended queue, and we now are keeping track of what his weight statistics are. And someone else gets to move up into that spot that he just vacated on the CPU. So again, I've got a link there for you about weight statistics. And this is a really, really good way to start a troubleshooting exercise, is to look at your weight statistics. Now, there are a whole host of weight statistics that you really should ignore. For example, we just talked about lazy writer a lot, and you notice that lazy writer goes to sleep for a while, and then he gets up, takes a look around. Oh, okay, some have been used, some have not. Then he goes back to sleep again. Well, you don't really want to take a look at the lazy writer sleep weight statistic, because it's natural, it's normal, it happens all the time. There's nothing you can do to improve it or change it. So just ignore that one. And there's lots of those kinds of weight statistics. Again, there's also a dirty dozen of weight statistics that I have in one of my webinars as well, called end-to-end troubleshooting checklist is what that webinar is called. Goes through the most significant and most frequently encountered weight stats. And the reason it's so important is if you were to take a look at your SQL server that you're trying to tune, and you're like, I think it's probably this new code that was introduced in the last run, the last deployment. So let me just tell the developers to go back and improve their code. But if we were then to go and look at the weight statistics, we might see that we have all kinds of page IO latch weights as well as memory weights. And what that would probably mean is that the IO subsystem is having trouble keeping up with all the requests and loading things up into memory. And so maybe you've got a really old, slow SAN in place that needs an upgrade or something like that. So it doesn't tell you what the exact problem is, but it puts you into the right category so that you know how to narrow your search. Okay. All right. So one last thing I want to kind of wrap up with, which is the idea that let's do a little doing the math kind of exercise here of how SQL Server looks for an optimal, a good enough plan rather than the best plan. So let's take an example scenario. We've got 4 tables, A, B, C, and D, and each of the tables has multiple columns. They have a clustered index, and they have 3 non-clustered indexes on each of those columns. And we're writing a simple select statement where we say select some columns from the tables. From table A, join to table B based on this key relationship, and C, and so forth, right? So let's do the math here. The first thing is, per table, we've got 4 tables. Per table, we've got 72 different ways that SQL Server might try to use those access methods to access the data. For example, it might do ordered scans or unordered scans. It might do ordered seeks or unordered seeks, right? So it does all these, it has to choose between all these different things for each table, 72 of them. Then on top of that, remember I mentioned join orders? Here's an interesting thought for you. If you have, I think it's more, if you have a 16 table join in a single query, that tells SQL Server you've got more than 2 trillion plans that you could potentially have based on join order. So again, in a dirty dozen of things that developers do, if you have a query that is just super massive across lots and lots of joins, there reaches a certain point where you may get better behavior, better performance by, say, joining these 3 into a temp table and joining these 4 into a different table, and then joining those together, right? Because the query optimizer has much easier calculations to make to determine what's the best execution plan. Okay, so that's just the join orders now, 24 on a 4-table join. And then on top of that, we have things like the 3 different ways that SQL Server does actual join. So it uses nested loops, it uses merge joins, and it uses hash joins. In a more recent release of SQL Server, they added something called adaptive joins, but that's not specifically a new kind of join. That just gives SQL Server more options to choose the best join closer to the time of execution. So it might choose between a merge or a hash join. And then there's all kinds of intermediate operations that might need to be happen. So SQL Server might say, oh my gosh, I've got to spill to tempdb and create a temporary table that I didn't realize was needed. Well, it realized it. We didn't realize it, right? So an example of that is if it chooses to do a hash join, it will always create the hash table in tempdb. If you have a group by clause, a lot of times SQL Server will create a temporary table. If you have an order that is different than the order of the indexes that are your primary indexes in this query, it may have to reorder those in tempdb. If you have a group by with a having clause, it's definitely going to do all that work in tempdb. So just on a 4-table join, we've got 26,000 different options for SQL Server to create the best plan. So really, when I think about that, I'm like, okay, SQL Server, you're doing pretty good, all things considered, in terms of your timeliness in returning queries. And so, you know, that's the joke, is that SQL Server doesn't try to get you the best plan. It tries to get you a good enough plan, just so that, you know, you won't come in with a baseball bat or a cricket bat in anger and beat it up, right? Okay, so with that, we're at the summary point. Okay, don't forget ACID. Once you've learned about ACID, you'll see it pop up all over the place as a subtext to what's happening. Atomic, consistent, isolated, and durable. The key components of the relational engine, those are the parts across the top and on the side. So that would be the parser, the binder, the simplifier, trivial plans, and then we have the search phases of the query optimizer phase 0, transactional plans, phase 1, quick plans, and phase 2, the full plan. Storage engine has the access methods, the transaction manager, and the buffer manager. Key areas of cache. You always need to remember the data cache and the plan cache in the buffer pool, but there are lots of other smaller ones too that are important. And what are the two processes that keep up with data and keeping things clean, like finding out whether they have, they're the least recently used item? So those are the checkpoint for clearing dirty pages, and then for maintaining the caches and doing garbage cleanup and so forth, that's the lazy writer and the ghost cleanup process. Okay. Transaction manager has two important components. That's the lock manager and the log manager. So that takes us to the end. What other kinds of questions can I answer for you?
So we had one that was a little off topic, so that's why we waited until the end. And it's in the chat window. So Mike was asking about that he currently uses SQL Sentry for SQL Server and has done for a number of years. They recently did an upgrade to V21 and has noticed that the memory graph on the performance dashboard now shows stolen buffers, or what he prefers to call repurposed buffers. I noticed this morning that one of my gruntier servers had quite a large percentage of stolen buffers, and it made me wonder, what was SQL Server repurposing my buffer cache pages for? I haven't looked very far in it yet, but given who our presenter is, I'll ask the question. Have you got any ideas or any insights into how the change in SQL Sentry is now showing these stolen buffers or repurposed buffers?
So basically, it's when SQL Server repurposes memory pages, and I'll be honest in that I haven't really studied deeply on it. I think the most common situation in which we show it, it can occur in like due to repurposing pages in the plan cache. from one execution plan to another. But in our case, I think what we are actually showing is when it's data is being used across NUMA nodes. So if you have, and again, I may need to go back and research this for you. And I apologize because I have actually had a conversation recently about this and was speaking knowledgeably, but right now it's not coming to me. But I believe that it has to do with that the buffer cache pages are being taken from one process or one set of activities and used in a different ways for other server requests. So could be something like the hashing operations, to put them into the plan cache. It could be things like a dynamic SQL query. According to one set of parameters, the query is really small, but according to another set of parameters, the query is massive because it's dynamically constructed. And so that's probably what it has to do with, is that it's moving things in and out of the probably the plan cache, and is doing that so quickly or so frequently that it's having to borrow memory from other parts of the plan cache to make all of your work happen within a reasonable amount of time. And when you say gruntiest servers, you mean one of your biggest and stoutest and most heavily used servers, or do you mean one of your oldest and most neglected servers? Not sure what the meaning is for that one.
So commonly for us, yes, a grunty server or gruntier server is a big beast that, it's got plenty of grunt to do that work that needs to happen.
Got it. Okay. Yeah, my bad on that. Don't know all the Australian slangs like I should.
That's okay. Mike, does that answer your question?
Yeah, I guess the main thing I was getting at was, do you have any tips on how to figure out what the memory is being repurposed for? And I was doing a little bit of reading, but I hadn't got very far into it before this seminar started, so I hadn't really summarized it. But one of the common things that came up that Greg just mentioned is large stored operations. And I was just thinking perhaps I can do some kind of aggregate query against DMOS memory clerks or DMOS memory buffers or one of those DMVs to try to see where my buffer cache was disappearing to.
Yes, that is true. And I do have some queries like that can tell you exactly what the top consumers of the different memory clerks are. If you'd like to see, let's carry on the conversation in email, and I'll get those out to you so you can take a look at it. I also like to just make sure that you're getting good service as well on that. So if you'd like, I could talk to the one or more of our product managers and get a more thorough explanation for you.
Sure, that'd be great. Thanks.
Excellent. Now, let's see here. Shall we give away a copy of the ebook?
I think so. So what I've done in preparation for this, I've put everybody who's still on the call, I've put them into an Excel spreadsheet, and okay. I'm using the random between values to randomly generate a number so that, or actually what I'll do is, Kevin, have you got an Excel spreadsheet open?
I have a 10-sided die. How about I use that?
Sure.
All right. Yay, for my old D&D stuff, right? Let me grab it.
Just while we're waiting for Kevin to come back, if anybody else does have any other questions that you would like to ask, please feel free to either take yourself off of mute, put your hand up, or put the question into the chat window.
Indeed. Was D&D ever popular in Australia?
Yes.
All right. Well, I was really surprised because I played a lot back in the times when evangelical Christians were telling me I was, a tool of the devil by playing D&D in the 80s and stuff, but now it's super popular. So number 5 on your list.
Number 5 is Martha. Martha, if you would like to just drop me an email with your contact details, then I can arrange with Kevin to get the prize out to you. And if you don't have my email address, I'll quickly just put it in. There we go. And it's in the chat window. So if you want to drop me a line, then I'll work with Kevin and we'll get you your prize. So John, I see you've put your hand up. Would you like to take yourself off mute? There we go.
Hey, yeah. Hi, Kevin. So I have a question.
Hi.
You mentioned if you have more than 12 table joins, it doesn't do as much work to get a good query plan. But I've noticed that even if I have like more than 6 table joins, I can just, let's say I have an 8 table join, I can take out 2 of the tables and do it like in a temp table, and that speeds it up like drastically. Is there some magic thing that's 6 or 7 tables that makes a difference?
Yeah, actually, if I said 12 tables makes it less hard, that's not true. The more tables that you join in a single query, the harder it has to work. And at least in my experience, I usually start to get very much more intense in terms of trying to tune my query if I think I'm going to have 6 or more. Actually, in fact, 4 is usually as much as I'll do without thinking a lot about the query. If I have to go to 5 tables, then maybe I need to reconsider my strategy. Like you said, maybe I need to plan on using temp tables, and put some intermediate result sets into temp tables rather than join all of those in a single query. And also, too, it's important to mention that it doesn't just mean the word join, right? So if you have a correlated subquery, in your select item list, so you've got something that says, this value, and this value from a table, and then parenthesis select from another table, a sum from based, where the outer table's ID equals the one in that's a join too, as far as SQL Server is concerned. And in addition, if you have like an apply, that's basically a specialized kind of inner join. So that count might even be higher than it initially appears to be because I was just counting the join statements. But if I have other kinds of behaviors in the query that are similar to joins, then SQL Server counts them in that way as a join, and those two can really add to the amount of processing overhead. Yes, and that's a great question. I think it's one of the things too that I've seen that really does separate the more experienced SQL developers from the less experienced ones.
Yeah, what's weird to me is that if I can do it manually, why can't SQL Server figure it out on its own that it's better off to take some of those joins and process it that way?
I have a blanket answer for questions like that. It's probably not the best answer, but the gist of it is, the query engine is pretty hard to make a big set of changes in. It takes a lot of work. And so one of the things that the Microsoft program managers will tell you is we always have a long list of things that our customers are asking for us to do. And then we also have our overlords in HQ who are looking at the financials of all of our products. And so a lot of situations in which something that will make SQL Server perform a little bit better, a little bit faster, those go to the end of the list compared to features that will help us sell more licenses of SQL Server. So kind of a similar question that we've seen a lot over the years, all of the MVPs on this call, would be people asking about why does SQL Server still have the same default configuration settings that it had in version 7, or that it had in version 2005 when a new feature was introduced, say max degrees of parallelism and cost threshold for parallelism. Those values that are a default made sense in 2005. They don't make sense 16 years later, where we have servers that have 2 terabytes of RAM and 256 CPUs. Well, if they were to change those, and recode the engine to have different defaults, A, it's a massive amount of work. B, how do you make that into a bullet point that will help you sell more products? And then C, there's the whole, the whole market context of, well, we got to introduce these XYZ new features to support competition against Oracle and Postgres, and we have to, build some more scaffolding, some more frameworks inside of SQL Server to work better in the cloud. So there's just ferocious competition for any new feature or change to the engine. And at the end of the day, people above our pay grade make the call. And it's typically what will help us sell more features. It takes a long, long time for things that really do improve the performance of SQL Server, but are hard to code. It takes a long time for those to get into the engine. There have been, as a sidebar to that though, I have seen some third-party products that you can buy that do those sorts of things. So another example of something that, well, why doesn't the optimizer just do this itself, is if you have an OR condition in a query, or if you have a where such and such a value is in and you have a list of values, that's basically the same as saying where my parameter is this value or this value or this value. Well, one of the things that you can do as a dev is you can actually rewrite that OR into the same query, but with union statements for each of the different conditions. And there are times when SQL Server will be able to find an index that it couldn't find otherwise, or maybe it can because the way those unions are working, and maybe they're joining table data from multiple tables. It's possible that it couldn't find an index on one table that it needed when you had the ORs, but now that you've turned it into unions, that one table that does have an index it can use does get the index, and so the total amount of work gets processed more quickly because you switched over to using unions. But like you said, in the same way, why doesn't it help us with multiple joins? At the same time, SQL Server doesn't rewrite ORs or in lists of items as unions, even though there are ways you could do that. You could build a tool to do that, or you could have the optimizer do it automatically. So it's a good question. I think the answer is probably not one that we love, though. Great question.
Thank you, John. Thank you, Kevin. Okay, so if nobody else has any other questions, I'd like to say thank you to Kevin for giving up his time and delivering this session for us. I'd like to say thank you to all of the attendees for being part of today's session. As mentioned at the start of the session, this session has been recorded and will be placed up onto the YouTube channel. With that, our next meeting is in a couple of weeks' time, and we will be talking on, bear with me, my internet's going slow. So on the 11th of May, and we will be developing a HTAP analytical solution with Cosmos DB and Synapse Analytics. So I look forward to seeing you all on May 11. Stay safe. continue your learning. Thanks, everybody.
Thank you, everyone.